Blood seal, like right here.
Okay, here we go. Here we go. All right. Listen up. You guys, I'm getting out of your notes, so the note packet I gave you just is not going to be your note packet for the next day or 2 or maybe 3 days. We're going to try to get this little booklet done in 2 days. The 7th and 8th page I didn't even talk about yet in last period, and 4th period I did talk about, but we ran out of time. So my goal is pages 1 through 6 today, and if I get through 6, you know everything you need to know. Okay? All right. Now, today's not bad, but tomorrow we do the story problems that go with this, and that's when things get a little rocky tomorrow. It's going to get kind of weird on you, but if you do today's lesson, and you listen and you do today's book assignment, you'll be fine tomorrow. Okay, but you got to do the book assignment, or else if you skip it, you're in trouble. Before you leave, grab some draft paper. You have to grab 8. 8, what they call feasible regions, and feasible regions are a bunch of inequalities where you shade up and below and all that. So it's going to take you probably 25 minutes or more. All right, so here we go. These are your I can statements, and I'm just hustling. I'm going to get going. And I'm going to tell you right now, since this is recording, I'm going to say go to YouTube to get your definitions. Now, if you want to copy as I'm talking, that's fine. You can copy. It's up to you. But I don't think you're going to be keeping up, so maybe YouTube would be better. If you don't want to do the YouTube thing, you can go to your book. Your book has the definitions. It's just that I didn't like their definition sometimes, so I did change their definition a little bit, slightly, okay? But these are my definitions of what linear programming is. Okay, what is linear programming? It is a method for finding 2 things. The minimum and the what? Maximum values, I forgot my S. The maximum values of some quantity given a set of constraints. Okay, minimums and maximums, here's what happens. We're talking business, guys. And when we talk business, we're talking maximize your profit, minimize your cost, okay? That is all down here under the objective. You can see it down here, okay? Now, the constraints. There will be constraints to your problems. The constraints, if you just want to think of them as what?
Inequality.
These are just the inequalities that they give you. X plus y is greater than 10. 2x plus 4y is less than 12. They're just inequalities that limit the possible solutions. And the solutions are now called your what?
Feasible region.
Feasible region. This is the region you will shade once, twice, 3, 4 times, and you'll shade it heavy and dark, and this will be where all the answers are, the feasible region. Oh, look, here's the feasible region word again. It's the shaded region that we created by the intersection of your constraints. And your constraints are the inequalities that we talked about. So basically, whatever you shade over and over and over is the feasible region. Now there is an objective to this. Why are we doing all this work? The objective is to maximize your what?
Profit.
Profit. Or minimize your what?
Cost.
Cost. Now guys, picture yourself as the manager at Target. You're the manager at Target. You walk into the door at 8 in the morning, all you're thinking of is one thing. How do I maximize my what?
Profit.
Profit. And guess what? They also think about how do I minimize my what?
Cost.
Cost. Now cost to a manager at Target would be, what's the cost?
Like when they get the products in by the truck.
Okay, so you're telling me when I buy 42 pairs of sweatpants, that's cost, right?
Mm-hmm.
Yeah, it is cost. Maybe I don't want to order 42. Maybe I should only order 30 or 27. I'm trying to minimize my cost. How about your employers? Not employers, employees.
You want to limit labor?
Do they cost something?
Yeah.
Yeah. If I'm the manager, I got to pay these people to work for me. Their cost. I want to minimize my cost, but I want to what?
Maximize your profit.
Maximize my profit. That's why we're doing this. And that's what businesses do, especially the bigger business. They get into this stuff so they can make a lot of money. Okay, when you graph that feasible region, there's a bounded answer, and then there's a unbounded answer. Well, a bounded is everything's enclosed. So what do I mean by that? Your answer might look like this today. This is a line, this is a line, and you shade it below each line to the right of your y-axis and up above your x. That would be a bounded feasible region because you've got boundaries everywhere. You can't go over certain lines or to the right or to the left. So what's unbounded? Well, unbounded would be like this. Okay, this is when you have, let me go like this. Here's a line. Here's a line. Unbounded would be if your answer happened to be over here.
Or just kind of everywhere.
Why is it unbounded?
Because there is no.
There's no limit. I can go forever up. If I can go forever up, this is an unbounded kind of feasible region. There is probably no maximum, but there's probably a what here? There's probably a minimum. Okay? Okay, and then this right here. The vertex principle of linear programming. What about the vertex? If there exists a maximum or a minimum, if there is a maximum or a minimum of the objective function, it occurs at one of its what?
Vertexes.
Vertices. So where do maximums and minimums occur? At the what?
Vertices.
Vertices. Where is a vertice? Right here. Vertices are where the boundaries meet. This would be a vertice. This would be a vertice. This one, this one, this one. So how many are there? 4. There are 4 possibilities that could create a maximum or a minimum. You pick those 4 points. You stick those 4 points into the objective formula that they'll give you. Once you stick it into the formula, you pump out the maximum profit or the minimum cost. So that's what you're doing today. Does that make sense at all?
Mm-hmm.
Somewhat? Okay. All right, here's a picture, and you can't see mine, so I got to redraw it. I think can you see yours?
Yeah.
Okay, slightly, right? So there's your XY axis. Here's your graph, right? Something like that, that, and this, right?
Mm-hmm.
Now, yours is shaded in here. Just so you know, it is shaded inside. I'm not sure if you can see that.
Nope.
Okay. All right, here we go with the 4 words. You gotta know what these are. What are the constraints? The constraints are actually, Taylor said boundaries, but actually they're just the inequalities. These are the things they're going to tell you. They might say something like this. See this boundary line? That boundary line is going to be y is less than or equal to negative 1/2 x plus 5. That is a constraint, an inequality. Hey, I'm just curious. Do you guys know this one right here? This vertical line?
X is greater than or equal to -3.
Yes, that's it. Guys, x equals a number is a vertical line. So this would be x is greater than or equal to -3. What about this horizontal line? Any guesses? Is it -1? -2? Okay. Okay, and I'm not going to do the other one, but there would be another one right here. Okay, these are constraints. Okay, so what's this? The objective function. The objective function is you making profit, a lot of profit, or you minimize your cost. Well, look up here, guys. The objective is going to be given to you today. In this case, it's got the letter C. What do you think C stands for?
Cost.
Yeah, that's cost. Okay, so this is a cost formula. So if you want to minimize your cost, put your vertices in there, and you will get it. Okay, where's the feasible region? Where do we find that?
There.
It's where we what?
Shaded.
We shade it. So this would be the shaded region. So would it be okay if I just wrote this in here? This is the what?
Feasible.
This is the feasible
Region.
region in here. This is where we find all the solutions. And then, hey, those are where all the solutions are, but where do we find maximum profit? Right there. It says right here, vertices. Vertices. This is where you find something like this. Wherever the lines match up, and you get this feasible region, this would be the vertices, wherever the corners are. This is where you find your what? Maximums, maybe your what? Minimum. Okay? You will find your maxes and your mins at the vertices. So maybe go up there and maybe show me some vertices. Or show yourself some vertices. They would be where?
-3, -2.
Right there. Is that -3, -2? Okay, I can't tell. There, there, and there are your what?
Vertices.
Vertices. Okay, I'm not going to write that word 4 times, but that's what it is. Vertices. Okay, now, here's the deal. Do you understand? You know how to do all of this.
Yeah.
You guys know how to graph inequalities. It's not like I'm going to surprise you. But the words I use with you, these are brand new words, and this is kind of a new system to you. So let's see what happens as we go. Let's go graph a feasible region. How do you do it? Right here, this is how you do it. You can copy that, or you can just listen to me, but last hour, I changed the colors to make it a little better, so you can see it better. So let me get a little larger for you. Okay, and maybe change a color for you so you can see it better.
It's right next to where you're
Where am I at? Okay, that's not it.
right.
Text. You were just, yeah,
Wouldn't that be it?
I don't know.
pretty sure. Only
Maybe,
go to the
maybe
little
not.
color box.
No. It's gone right now. Oh, I know what it is. Hang on.
Oh,
That kind of got big, didn't it?
yeah.
Okay, let's go like this.
Yep.
That's a little too big, I think. We're gonna go.
Yeah, just a little bit.
Let's go 36 down to what? 24.
That's
Okay.
where you were at.
Okay, better, and then we'll go color right there.
Oh, well,
Okay.
sorta.
Is it better or not?
No, I was right. This will go back to the color.
Okay.
Nobody heard you.
It says, to do this, when you want to graph inequalities, write your constraints in slope-intercept form. Although, I'll be honest, I wouldn't do it. I wrote the word what? Or just graph the xy intercepts when the equation is in standard form, ax plus by equals c. I think that's the easier way to do it, faster. Okay? Once you graph, then what do?
Shade.
Oh, you shade, you're right. I forgot, I'm one step behind. Okay, let me go a little bigger. So we're going to graph each constraint, and then we're going to do what to the constraints? Shade them. Okay. Okay, shade them. All right. Then once you shade them, the feasible region is where all the shaded areas overlap. So you might overlap one region 4 times or 5 times, okay? Just so you know.
What if you overlap a couple regions, but one region has
All the region, it has to be shaded. If there's 5 inequalities, it has to be shaded 5 times.
the one region?
Yep,
Okay.
yep. It's just the way it is, I guess. I can't change that. Let's go blue.
It's green. Let's go green.
You like green?
I like
Okay, here we go.
green. Let's see black to begin with.
All right, next. Here's our problem. Let's go. Let's go. We got how many inequalities up there? Count them.
5.
5. I count more.
What? 1, 2, 3, 4. What? 6.
I count 6.
6. Look at the top one.
Yeah, the first one's 2. See this one right here? That one, and then there's this one. Okay, so this one I'm going to rewrite it up here. Looks like this. Okay, so now when I do this, I'm going to ignore the left side. Because I wrote that right here. Okay, so there are 6 inequalities, which means you're going to tell me the feasible region is where it got overlapped 6 times, shaded 6 times. What's this look like? Is it horizontal? No, x equals the number is vertical. You guys should be saying vertical, x equals 0, straight up. So x equals 5, straight up. Okay, and straight down. Okay, now shade. When you shade greater than 0 on both of them, you're going to shade where? Shaded greater than 0 would be where? To the right. Okay, so I'm shading this way. Okay, but the next one says what? All x's less than 5, that'd be this way. So right now, you should be looking at this saying the 2 parallel lines, everything in between, that's the feasible region right now. Here's the problem.
It's not how it's always been.
We got 4 more to do. Okay, so what's this one look like right here? What's that look like?
Horizontal.
That's horizontal. So if it goes right through the y-axis at 0, it would be right here. And since it says what? Greater than or less than? Greater than would be shaded
Above.
above. Okay. There is absolutely no reason for me to do this, right?
Mm-hmm.
Okay, so should I do this?
No.
No, the answer's right here. So why don't I just go inside there? This is the answer right now. Okay, that's what I see. Okay, so far, now the region just got smaller. Okay, what about this one?
Find the intersection.
I do the intercepts too. Guys, you can solve for y, then graph it. But I would, if I were you, just do quick intercepts. If you let x be 0, 0 plus what equals 7? 7. If you let y be 0, what plus 0 equals 7? 7. Right? Okay, well, you got 2 solutions. Go graph them. 7, 0 here, 0, 7 up here. Graph them. And there you go. Now comes the time to shade it. Below or above? Below?
No.
Here's the deal. If you're reading the sign, don't do it. It's in standard form. You should plug in what number? Or what point? 0, 0. Okay. 0 plus 0. Is 0 plus 0 less than 7?
Yes.
Yes. So then go ahead, shade this side. Okay, so here I go. Down, down. Now there's no reason to go on because it's in between the 2 parallel lines. So right now, here's what I see. I see basically just an outline of it is here. This is the outline. That's my feasible region right now. But I still have how many to go?
2.
2 more. Okay, let's get this one. Okay. Adrian, do you have the XY intercepts or did you do it the other way?
I did it the other way.
Okay. Who's got my XY intercepts on this one? If I let x be 0, cover up the x.
It's
It'd
2.
be 2.
Divide by 2, you get 2. Let y be 0, cover up the y term. X equals 4. There it is, 4, 0, 0, 2. Okay, so that'd be here. 4, 0, 0, 2. Yes, I did it right. Goes like this. Okay. But where are you going to shade that one? Above or below? Put in 0, 0. 0 goes in. 0 goes in. Is 0 plus 0 greater than 4?
No.
No. Don't shade this side. Shade what?
Above.
The upper side. Okay. Now my answer just changed again. The region keeps getting what? Smaller.
This is getting to me.
Okay, next.
Just don't
This one's in
shade
slope intercept form. Just graph it. Let me go green. Slope is 1 over 1. Whoops, that's a 1. 5 up. 2, 3, 4, 5 up. Slope of 1. There it goes, and there it goes, right? Okay, shade where? Y is less than. Shade below. If it's solved for Y, you can just read the sign. Now, shading below, there's absolutely no reason to do this, right? Why would I do this? You're just wasting my time. Get inside your feasible region right here. That's it.
It's just,
That is it. Below. Now, where's the rest of the answer? Right here. Follow my green pen, please. There it is. We call this the what?
Feasible region.
This is exactly where all the answers are. Now, help me out. We're not going to do this. We're not going to do this, but help me out. Where will the maximum profit occur? At the vertices. How many vertices do you guys count? You count 5?
3,
6?
4, 5, 6.
1, 2, 3, 4, 5, 6. There are 6 vertices. On the next slide, you and I will have to get those vertices, plug them into the formula, and work it out. Okay. That was graphing a feasible region. Turn the page, and then we're gonna do it again. But this time when we do it, we're actually gonna go find what?
apparently the verse.
The vertices. Okay? Okay. How do you test vertices? Look up. You don't have this on yours, right? Start copying.
Oh.
You could just write this word right here. Graph the feasible region. You and I just did that. We just did that a second ago. Follow the steps for sketching a feasible region. We just did it. So go back to the previous page and just follow those steps. Now, once you get it graphed, identify what?
Vertices.
You got to go identify it. When I say identify, that would mean you'd have to say this. X, comma, Y, like 2, 4, 6, 1, 3, 0. Okay, just get me the vertices. All right, step 3, once you get the vertices, okay. Oh, sorry, this is kind of tricky. If necessary, create a what?
2 by 2.
A 2 by 2 system to help you. Watch. If you want the vertices right there, you might have to say this equation, 2x plus y equals 10, and this equation, x plus y equals 4. You might have to set a system up like that. That's what I'm saying. That's what a 2 by 2 is. You might have to set up a 2 by 2 system and then solve it by elimination or substitution to get that intersection point, x comma y. Okay? So how do we do this? We solve it by what? What method? Yeah. You might have to solve it by substitution or elimination. And you know what we're hoping for? We're actually hoping our eyes are good enough and our graph is good enough to pick up that point. You don't want to have to do that, guys. You want your graphs to be perfect. Because then you can probably pick out your point. Last but not least, here's what you do. Test your vertices. Where do you put your vertices? Where do you put them?
In the objective function.
In the objective function. This is given to you today. Tomorrow, it's not. Tomorrow, you have to dig it out of the story prompt. Today, it's given to you, okay? All right. Look in the book. All these steps are in the book. Go to YouTube tonight and just copy this information. Really, to be honest, I think when we do the next slide, you guys, this will make so much sense to you, okay? Here we go. There are how many inequalities? 4. 1, 2, 3, 4. You will have 4 lines. You will shade 4 times. You're looking for the region that has been shaded 4 times. That will be the feasible region. I'll give you a 2-minute head start. Ready, set, go. Go grab it. there's more. So they have zero. Sure. Oh, yeah. If you need some help graphing, let us know.
Mhm.
There's 2 cents less than
First two are less than.
okay.
We're doing Yeah.
Okay, you know what, guys? When it says x is greater than 0, y is greater than 0, you know where they locked you into?
The upper right.
They locked you into which quadrant?
The positive.
First.
The top right, which is known as quadrant
One.
1. That's 1. Where's 2?
Across
No,
from it.
2's over here. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. You are in the positive region. That's where you're at. Okay, now, let's go here. XY intercepts. Anybody want to say it? Nobody wants to say it? 0, 6, yeah, 0 plus 6 is 6. And 6 plus 0 is 6. That's pretty simple. I wouldn't solve for y. If you want to, go for it. Okay, this one. X-intercept, y-intercept, a little tougher. If you let x be 0, look right here, guys. I'll put a 0 here for you. Divide by 2, what's the answer? 4. 0, 4 is the y-intercept. If you want the x-intercept,
No.
let y be 0. Okay, and now what happens?
Yes.
Now it says what?
Yeah,
X
that works.
equals
It's just minus small numbers.
8.
Because I did by twos.
Oh, yeah.
Good?
Fine.
Okay, let's graph.
You're good.
6, 0. 6, 0, and 0, 6 is right here. Here goes the line. Okay, shade where?
Below.
Below. Because if I try 0, 0, if I do try it, 0 plus 0 is less than 6. It's good. Go below. Do you already see it's the triangle?
Yeah.
Okay, there you go. Where's the other line? 0, 4. 0, 4 is here. And 8, 0 is here. There goes. And there goes. And you will shade where on this one?
Below.
0 plus 0 is less than 8. Yeah, shade below. Now careful, shading below the green only lasts so long until you get where? Right there. Now you gotta shade below the what? The blue. Now above the red. You see it? There it is. This becomes what?
It's feasible region.
Feasible region. There you go. Now, you now need to pick out the vertices. Okay, this P right here, I'm going to change this on you. You might want to rewrite this. Write it as P for what?
I don't know.
P for what?
Oh, probably.
Profit. So write the profit formula is 3 times x plus y. Okay? There. Now pick out the vertices. Here's one, right here.
0, 0.
0, 0. Okay, what about this one right here? 0, 4. Okay, what about this one? 6, 0. Okay, it's gonna get a little tougher on you now. 6, 0. Now this one right here is the tough one if you're not good at graphing. If you're kind of sloppy, that's hard.
3-2.
Is it 4-2?
4-2.
4-2.
Okay, now, can I just tell you something? If you guys are ever guessing, there's no reason to guess. You don't have to guess. You know what you can do? If you want that vertice right there, this vertice is really just the intersection point of two equations. One of the equations was this, x plus y equals 6. The other one was x plus 2y what? Equals 8. Wasn't it 8? So how would you solve that system?
Elimination or substitution.
Elimination or substitution, and I'll just write the words just so you know. Either do this, substitution, or do this, elimination. Guess what you would get?
4-2.
4-2. 4-2 is the answer. And you know it's right if you just what?
Check.
It's 4 plus 2, 6.
Yes.
Is 4 plus 2 times 2, 8.
Yes.
Yes, it's right. We can check it in our head. I know it's right. All right, here it comes. You want to maximize your profit? Let's do it. Put your vertices into your profit formula.
0.
3 times x plus y.
0.
3 times 0 plus 0. Hang on. Okay, equals what? 0. Let's do the next one. 3 times x plus y.
4.
4. Next, 3 times 6 plus y. 18. 3 times 4 plus y. 14. Okay. Go up there and then you gotta write these words. Where's your maximum?
18.
18 is your max? Okay, so your maximum
yeah.
is? You go like this. You circle it. 18 is my maximum. Where does it occur? At what?
6-0.
6, 0. Tomorrow when you answer this question, it will say something like this. 6, 0, guess what? It will mean this. You have to buy 6 aluminum bats and 0 wooden bats, and you'll maximize your profit at what? How high can I get?
18.
I can make $18 if I order 6 aluminum bats and 0 wooden bats. Because tomorrow it's a story problem. Where's the minimum?
Minimum is 0.
Yeah. Where did this happen? At what? At 0, 0. Now that would make sense, wouldn't it? You don't buy anything. How are you
So
going to make money?
using that from now on. And it's C4.
So
Okay.
Diamondite.
You mean all these answers?
Well, no, not.
Like detonators and C4.
Yeah, because most of the time I'll be saying number of bats, number of aluminum and wooden bats. You're not going to buy negative. So most of our answers will fall where? In what?
First quadrant.
First quadrant, yeah. It's always in the first quadrant. Eventually tomorrow, guess where I start the origin tomorrow?
In the bottom corner. but
Yeah, that's where I go.
still Technically first quadrant.
First quadrant. Everybody, I want number 1 done. You got 7 minutes. Go. In your book. I'm not doing the next one. I'm not doing the next slide.
Okay.
Go to your book right now. Dig it out. Put it in front of you. Share it with your partner. If your partner probably didn't bring their book today.
Bring the bell.
No, this book's like literally right next to me.
Where'd you go?
No, just pick one. I don't want
No. No. You gotta. Hey, here's soccer guy. You can last forever.
What now?
Apparently we need to do number 1 or whatever.
Number 1, get going.
Did you need one?
Draft paper, anybody?
Yeah.
Over here, please.
Tyler Thompson. Those are good hands for
Remember when
Here.
you got kicked out of class?
Can I have another one?
1 or 2. You got someone next to you.
Those are good receivers. She's gonna be an All-American one day.
Page 160.
Are we gonna need more than 6 problems?
We need 8. We need 8. Take another one. Take another one.
I'm debating if I should get like one like this or should I get like
There you go.
fine.
All right, you guys. That was 1 minute of talking, and you haven't done anything.
I'm getting.
Get going.
Do you know what the assignment is?
No.
Do you need this?
You need some?
I can always use more.
Yeah, no.
I'll also take another one, so I'm just gonna photocopy
There's
this.
2.
Did you read that? Yeah, last time.
Okay. You guys, if you want your graph paper, there it is.
That's like all we talked about.
Okay, for you people that don't have a book, there's number 1, I believe, right?
Almost.
Is that it?
I think 160.
Oh, it's supposed to be less than 6.
That's the rate.
That's
Okay, go. Guys, there's no reason to sit around. Let's go. We got 5 minutes. There it is. You don't have a book. There it is. All you have to do is graph the feasible region. You do not have to pick out the vertices. You don't have to put it in the profit formula. There is no profit formula. Just graph it. Just shade it. You're done. Feasible region is nothing but a shaded region that has all the solutions. No, they get into like find a vertex, put it in the formula.
Just step.
All it is, you just stick it in the formula. Tell me the max. Okay, but this is an easy.
An easy problem.
Mhm. That doesn't make sense. It should say 9/26 to October 14th.
Yeah.
Yeah, it should say. That's it. But yes, we're on the linear program.
When the schedule makes sense.
All right. Hey, this one. X equals 0 is what?
It's X and Y.
Tell me diagonal, vertical, or horizontal?
That
X equals 0.
vertical.
Vertical. Thank you.
That one.
Straight up.
Y is horizontal.
Okay.
Okay. That's X equals 0. Shade where? Guys, X is greater than 0. It's either right or left.
Right.
It's right. Okay, this one. Y equals 0.
It's horizontal.
Would that be horizontal?
Yeah.
Okay, horizontal. Okay. Y equals 0.
Bless you.
Greater than. Well, it's either up or down.
It's up.
It's up. No sense in doing it over here until I get right about here. So now you're locked into what region?
Positive 1.
Your quadrant 1. I meant to say what quadrant. Okay. What about this one?
0, 6.
Yeah. I hope you went with this. Where'd you shade? Under, because 0 plus 0 is less than 6. 0, 0 works, shade under. There it is. Number 1 is done. We got the feasible region on paper. And we're done.
Did 1, 2, 3.
No vertices were needed. No profit formula, nothing. That comes later.
Comes at number 5.
Graph paper if you need it.